16th June 1819 in Kutch. The time is 11 and you can see higher magnitude. And this major earthquake happened at an intensity of 8. So here magnitude and intensity both are 8. Number of deaths is around 1500. And you can observe here it is highlighted. Even though the small earthquake, which is the Quetta earthquake 31st May 1935, at the night 3, the difference you can see that this is magnitude of 8.3 and this is magnitude of 7.6. So there is a variation of 1 magnitude. You know that already. If magnitude is reduced to 1, 31 times of energy it is getting reduced. So even though the magnitude is very less, you can observe the intensity. The intensity is 10 here, the maximum intensity is 8. So you know the variation between intensity, and if it is 7 versus the 10, there are much more weightages in the building. How the intensity are measured is according to the surrounding and whatever structure it is built and how we are perceiving that. Either it might be humans or the animals. How we are perceiving the earthquake. According to these three parameters, the intensity varies. You can see the intensity is much higher here and death is around 30,000 people. Is very less here, but the death is around 1500. And you can see there is a large variation, around 20 times of variation is been observed here. The earthquake which occurred at night, to be sleeping at that time. So the people couldn't observe the earthquake, the life loss gets increased. If any earthquake is observed in morning or at the daytime, the people can observe the things and they can act and react. You can see at morning 9 and 1897 Assam earthquake is at evening 5:11. You can see the death is very less, 1500 and 1500. And also you can see these are all the large earthquakes. The past, recent past, 26th of January 2001, which is at Bhuj. Morning at 8:46, the magnitude was 7.7 and you can see the intensity is 10. Wherever you see higher intensity, when you compare with magnitude and intensity, intensity plays a vital role in analyzing how much of life is being lost, how much of property is being lost. So if we want to calculate that, intensity plays a key factor here. You can observe with intensity with the death, but you cannot correlate with magnitude with the death. Wherever you find intensity is higher, you can see the intensity is 10 and the life loss is 19,000, 11,000, 30,000. These are all very much higher and you can see in Bhuj 13,805. If the intensity is less, 8, you can observe here this is 7 and life loss is only 30. So you can correlate the intensity with the death but not with the magnitude with the death. And these are all the highlightable earthquake. In 1819 Kutch earthquake, so this is the earthquake and there was an uplift of a ground. There is a fault and at the fault region to the end of the fault, the fault plate can be up to 1000 kilometers. And if you see the difference between the fault, there is an uplift of 3 meter. 3 meter is nearly the height of your building. So at one end where the fault is being visible, you can see a 3 meter of uplift ground over 100 kilometer. In 1897 Assam earthquake. So this is the Assam earthquake. The highlightable term is it caused severe damages up to 500 kilometer of radial distance. So when we are talking about the widening area of an earthquake and how much of effect which could happen due to an earthquake. So up to 500 kilometer is a really far distance in a state. If particularly you are mentioning any state, might be Maharashtra, and if any earthquake occurred in Maharashtra, it could be observed in that specific district only or state. when you are observing to another state. 500 kilometer is observing in another state also. So the earthquake crosses the state boundaries, and the Assam earthquake is being observed in 500 kilometer radial distance. So extensive liquefaction can occur when the water particles are more when compared to the soil particles. If you compare the density, you would have found in geological engineering there is a difference between water particles and the soil particles. There are solids inside that. When you go into deep inside the earth, so you can find not only the soil, there will be some water and there will be some liquid. So if the liquid is much more higher than the solid particle, then the soil tends to behave as a liquid. So this phenomena is known as the liquefaction. Slowly, if any force is been occurring, so it will behave like a fluid, not like a solid. Like this, an extensive liquefaction is being occurred over a length of 300 km called slump belt in Bihar Nepal earthquake 1934. Now, this map is being taken from IS 1893, and you can observe what are the earthquakes which happened in India. You can see number of bubbles or circles around the places. Can you highlight why at these portions? You can see these are all peninsular portion, and this is the northern portion of India. And you can observe here there are very much less earthquake in the peninsular part, and you can see the circles here. The circle indicate the magnitude of an earthquake. If the circle diameter is much higher, then the magnitude will be much higher. Number of earthquake which happened here. There is a Indo-Austrian plate which crosses with the Asian plate. So there is a plate boundary here. You could observe. So due to this plate boundary, there are numerous earthquakes which happen and which occur at these portions. If you want to make any construction which are much important, say for example it might be major dam. If you are constructing dam at this portion, you should be very keen. The dam might cause secondary effect also. Earthquake is a primary effect, but after earthquake, the dam can get cracked, it can get collapsed, the water can leak. So this is the secondary effect of an earthquake. You should be aware of where you are building the structure. For any larger structure, it might be dam, and second one is nuclear power plant. So there is a concept called microzonation. What do you mean by microzonation is you will be not taking only the Indian map. You will be identifying what are the layers of the soil which is available below, and you will be making the construction. The dynamic effect has to be understood there. Learning this, the seismic microzonation accounts for local variation, geology, local soil profile. So this is what I would like to highlight here. All the soil below the ground is not similar. You are finding different types of soil. When you excavate this place, you can see rich and hard soils will be available. But slowly, if you move towards the northern part, there are black cotton, alluvial. These soils are much more sensitive to water. If water is much higher, earthquake character changes. When the seismic waves are moving to, if it is traveling in a rock or hard strata, what happens? Whatever the earthquake wave is generated, you know that there are four number of earthquake waves are generated. They are P waves, S wave, love wave and Rayleigh wave. These four waves are generated at simultaneous time, and when it crosses into different soil, it behaves differently. If it crosses a hard soil, what happens? Whatever the waves are generated, it gets transferred most accurately up to 80 to 90% and it travels to the next portion. But what happens if your soil is very loose? If it is having water particles, then the amplification will get increased. So certain parts of land might have the hard soil, but soon after that it either might be in horizontal or vertical. After that you might find a different layer of sand might be having water particles. So what happens? The amplification becomes much higher. So whatever seismic waves are here, it might be an amplitude of 3, and if it crosses with the different soil, it might cross amplification of 8. So the vibration will be much higher here. So the local site effect which should be identified for a particular area. Here you can see from United States Geological Survey, these are the area where the earthquake wave is being traveled, and you can observe the rounds or circles here. If you observe the circles, they are not even and they are not common. So when you understand any earthquake, it should generate at a point called focus, and from the focus the wave has to generate and it should pass. When it is passing, it should pass in a same manner called intensity. So this is what in last class I have highlighted. What do you mean by intensity is, if you are nearing to a bulb, you will be get light, and if you move far away from the bulb, so your luminous intensity gets reduced. The same way, where the earthquake is occurring will be having much more higher intensity. If you move far away, the intensity should get less. Take an example, if an earthquake is occurring here, the intensity should get reduced and the amplification. What do you mean by amplification is, where the earthquake occurs, the shaking will be much higher. If you take to 100 kilometers, the amplification will be much lesser, and if you take to 500 kilometers, you will be not observing any shaking. If you understand from this map, you can observe that there are some odd areas. What are these odd areas? If this is the highest intensity, the intensity should reduce here. But why the intensity is not reduced? It is increased at a point. Why? Because this is artificial landfill. So you can see the red color part is called a artificial landfill. Okay, what do you mean by artificial landfill is, lay some layer of soil and it might be the passage of the water, the rainwater, and they will fill the land. Soon they will start construction and they will make a plot and they will sell. So this process will happen. But during an earthquake, what happens if we are filling the parts? And there are number of cases I have seen. The client will be very much interested in constructing building, but the land what they have bought is, when they are excavating for the construction, they will be identifying the wells. So the wells might be closed. For 100 or 150 years, every land, whatever you see now, agricultural land in past, but there will be well. For the temporary purpose, they will fill the land with the soil or sand. But soon after getting your land, when you are excavating or when you are boring, you will be coming to know that there was a well in your land. Okay, if that was your case, if you are making the construction there, it is not the soil what is developed by the nature. It is the soil which is developed by the human. But what happens in those area, when an earthquake wave is getting generated, the soil will be not having much compression enough, and the wave will be much higher and the amplitude will be much higher in these places. So this is what is highlighted in artificial fill. So these are all called artificial fill. Okay, in these portions you can see the larger round here. What do you mean by this larger round is, the amplitude much higher. If you are located in that portion, your building will shake much more to higher level. Possibility of having the collapse. Okay, this is the usefulness of finding the local site effect. Seismic waves will get modified due to local geological conditions. They are strongly influenced the nature and severity of the shaking. The shallow and softer rock, they slow down the bigger amplitude. If you are having rock soil site, this is where you are located now is a safe part. Why? Because the soil below, when making the excavation, it has been observed that it is a hard strata, and here whenever an earthquake is occurring at your place, it gets reduced and your amplification will not increase as the earthquake, it gets reduced. If you are having softer soils or encountering it, your amplification increases. If your soil is very strong, then the amplification gets reduced or slowed down. Okay. The total thickness of the soil bed is also an important parameter. The soil wide, you should understand the width as well as the thickness. So both the parameters plays an important role here. The total thickness of the soil to the bedrock, geometry of the soil deposit, can further distort the ground motion. Wherever you are constructing in a seashore or along the river, there is one advantage. If you are constructing along the river, you will be getting bore water, which is one advantage. But whenever you are constructing along the river, what happens? There will be water particles, and the water particles will be making the soil to lesser strength. The structure which are built along with the running water, which are much more effectable. Why? Because the soil is not stable. When an earthquake occurs, if your soil is very strong, it does not amplify the earthquake. If your soil is weak, then it gets amplified, and soon the earthquake makes the structure to get collapsed. The sediment filled valley can trap the seismic energy. What do you mean by trap is the seismic wave will be getting generated. Imagine that you are in a cave and you are making some noise there. What happens? It gets reverberated and you can hear 3 or 4 voices of yourself. So the same thing which happens due to an earthquake also. If any wave is entering into that sedimental soil, what happens? It traps the energy there and it amplifies, and you can see number of voices and echoes will be happening. The same way the earthquake waves also creates the number of amplification at different layers. So you should note that wherever you are finding the blue color are the places of sedimental trap, and in this area there is possibility of changing the higher amplitude and the longer duration of shaking. The seismic wave might be for a duration of 20 seconds, but if you are located in a place where you have soft soils, your earthquake might get increased and it can long up to 30 second also. So 20 second may increase to 30 second, or 20 second of earthquake might reduce to 10 second. Both the things can happen. Okay. Next thing is sedimentary basin deep geological structure. The earthquake waves travel at high velocity. If it travels in a stiff and crystalline rock, so you are not going to get affected. The crust refract and slows dramatically the vibration, but it increases the amplitude in the soft basin rocks. You can see number of amplitude of surface wave here and understand the picture. This is not a different earthquake. This is a single earthquake which happened, and at the seismometers are being installed at different locations. You can see at each and every location where the seismometer is installed, you can see the vibrations here, and at all the points you can see at particular point here the vibration is getting high. At these points the vibration are high, and if you identify the geological condition of that basin, you can see there will be soft basin rocks, and due to this the amplification is high. These are the two places where you got high amplifications. So these blue color lines which identifies that these are the soft basin, and in this part you got higher amplification, ground failure potential. So this is the local site effect. At a particular area you can observe this kind of soil. So this is known as liquefaction and landslide. The soil consists of three number of particles. It might be a solid particle, liquid particle, and there will be air. So if you take the characteristic of a soil, this kind of phenomena happens when your water content is more than the soil. So the soil behaves like a liquid. Wherever you are standing, this soil behaves similar to a liquid. So if you construct any house above that, what happens? The building will be first settling. So the settling will not be common. You will be getting 10 number of column. It might be having irregular settlement. So due to that irregularity, you will be getting cracks, and the structure will be having one effect there. And next one is it can have higher amplitude of vibration. The shaking will be much higher. So this is the second type of effect. The soil can get to differential settlement and subsurface is liquefiable. As a result of this, the failure can be very much large. And next thing is topography. Okay, where you are constructing your house, if an earthquake is occurring, and imagine that you are having a hill area and you are located at a plain surface. These are the two conditions. If you are located at a hill place, there is a possibility of having higher amplitude, and the same earthquake which has happened in the plain area, the amplification will be much lesser.